We're going to use the unit circle to determine ratios and angles. And in class, we talked about determining the values of the unit circle at different points along the circumference of the circle. So the first values that we determined were these points on the axes. So because this is 1 unit, the radius is 1 unit, the x value here is going to be 1, the y value is going to be 0. And I could use this, for example, so the sine of 2 pi radians. And if you remember, sine is the up and down guy, sine is the y guy, so the sine of 2 pi radians is going to be 0. Okay, and so we can do that around our entire unit. So again, as another example, I could ask you to calculate what is the cosine of 3 pi on 2. And because this is 1 pi on 2, 2 pi on 2, 3 pi on 2 down here, and cosine is the x guys, the cosine of 3 pi on 2 happens to be 0. Okay, so then we went on to find more value. And the next one that we took a look at was our pi on 4 angle here. So this green angle here is pi on 4, because I would be dividing my pi into 4 parts. 1, 2, 3, 4. Okay, because it takes me to pi all the way over there. And what we figured out in class on our paper plates is that pi on 4 had values of root 2 on 2 for the y, or for the x, and root 2 on 2 for the y. And that's going to be the same over here. It's the same values, but now we just have to consider when we're in quadrant number 2 that the x values are negative. So now it's negative root 2 on 2, but my y values are still positive, root 2 on 2. Okay, so for example, over here, I could say, oh, could you tell me what the sine of 5 pi on 4 is? And so you'd go, well, there's 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4 would take me down to here. Sine is my y guys, my up and down guys, so it's going to be negative root 2 on 2. I'm just going to label these all here are examples on this side. Good. Okay, so the next one we were able to get to in class was the pi on 3 angle, because we're dividing our pi, which is the half the circle, into 3 parts. 1 part here, 2 parts here, and 3 parts here. So this is my pi on 3 angle, and we figured out in class that the x value of this point on the circumference of a unit circle is 1/2, and the y value is root 3 on 2. And again, that's going to be the same over here, except we have to consider that the x is negative, so negative 1/2 and positive root 3 on 2. So for example, I could say, could you please tell me what the cosine is of, because we're dealing with pi on 3s, let's say 5 pi on 3. So this is 6 pi on 3 coming all the way around, so 1 pi on 3 less would take me to here. Cosine is my x, guys, so that would turn out to be positive 1/2. Okay, and finally, we didn't get to this one in class, but the last values are right here, and this angle right here is my pi on 6 angle. Pi on 6. So there's 1 pi on 6, 2 pi on 6s take us to pi on 3, 3 pi on 6, 4 pi on 6, 5 pi on 6, 6 pi on 6 takes us halfway around the circle. And the pi on 6 x and y value happen to be the opposite of the pi on 3 x and y value, and that's because of the special triangle. It's got root 3 on 2 and 1/2, and then over here negative root 3 on 2 and 1/2. Going along the same lines, I could ask you what the sine of let's say 7 pi on 6 is. So I know that 6 pi on 6 will take me here. 1 more pi on 6 will take me down to this point here. Sine is the y, guys, so it's going to be negative 1/2. Okay, so that's how we can use the unit circle to determine ratios. And I'm going to show you a different way. It's still based on this idea, but instead of having to draw out the unit circle every single time, It's called my 1, 2, 3 trick. So it's the 1, 2, 3 trick, but then we also have to consider the cast rule. So for you to remember what the points are for your pi on 6, pi on 4, and pi on 3 angles, this is how the trick works. We're going to write the numbers starting at the top, 1, 2, 3. Then we're going to shift over and we're going to write the numbers 1, 2, and 3 again, 2, 3. And now for each one of these numbers, we're going to put it over 2. And over here, over 2, over 2, over 2. And then the last thing we're going to do is we're going to take the square root of every single one of the numbers. And what we have here are the x and y values for, starting in order, the smallest angle, which is pi on 6, and then pi on 4, and then pi on 3. So the only other thing that's left to do is to kind of clean these up a bit, because the square root of 1 over 2 is just 1 over 2 and root 3 on 2. So the x value is a half, the y is root 3 on 2. In this case, root 2 on 2 and root 2 on 2 stay as they are. And down at the bottom, we have root 3 on 2 and then 1 on 2. And so if I asked you to determine, for example, what is the value of the sine of, let's say, 7 pi on 4, then what you'd first have to do is you'd have to determine, okay, if I'm talking about 7 pi on 4, which quadrant am I talking about? So let's draw that angle in. Okay, so I know that this is going to take me to 4 pi on 4. All the way around is going to take me to 8 pi on 4, so I'm going to be 1 pi on 4 less than that. So I'm going to come to here. There's my terminal arm. So this is going to be the angle 7 pi on 4. What that tells me then, too, is that this little angle in here, we're going to call our related acute angle. And our related acute angle is the pi on 4 that's left over, is just pi on 4. Since I know my related acute angle, I can go up to here where my pi on 4 angle is, and I could determine, hey, for sine, I need to consider the y guys. So I could say, okay, the related acute angle is pi on 4. So I know that the sine of pi on 4 is going to be root 2 on 2. But I also have to consider the cast rule. And the cast rule says that in this quadrant, only C has a positive ratio, and then A, and then S, and then T. So in this quadrant, since only C has a positive ratio, then I could say, well, the sine of pi on 4 is root 2 on 2, but the sine of 7 pi on 4 is going to be the same value, but I have to consider, hey, only cosine's positive here, and I'm dealing with sine, so it's going to be negative root 2 on 2. Let's say we're talking about the cosine of 4 pi on 3. So I have to first determine where 4 pi on 3 is. So halfway around my unit circle is going to take me to 3 pi on 3, and then I'm going to go 1 more pi on 3 past that. So I'm going to go like this, and that's going to be 4 pi on 3. What that tells me, again, is that this little angle right in here, my related acute angle, is going to turn out to be pi on 3. It's 1 pi on 3 after 3 pi on 3. So then I go back up to my 1, 2, 3 trick, and pi on 3 has cosine pi on 3, and cosine is our x values. It's our back and forth guys. The cosine of pi on 3 is equal to 1/2. But then I have to consider, but wait, in this quadrant, only tangent is positive, so the cosine of 5 pi on 3 is going to equal negative 1/2. Okay, we're going to do this one more way. And what we're going to do is we're going to consider, instead of determining what the angle of measurement, or what the ratio is, we're going to determine what the angle of measurement is. So let's say I asked you to determine the radian value of theta if, and I'm going to put some restrictions on theta, theta falls between 0 and 2 pi. And I have to put those restrictions on theta because we're talking about sinusoidal functions that are just going to continue off into infinity. So there can be an infinite numbers of values of theta unless I put some restrictions on it. So let's say, for example, I asked you to determine what the value of theta is if the ratio is a half. So the one way that I could approach this is I could go all the way back up here to where the values are a half for sine. I'm saying the sine of some angle is equal to a half. Well, we know that sine is our y, guys. So let's see. The y, guys, where is y equal to a half? Oh, at pi on 6. So what I'm going to say here is I'm going to say, okay, my related acute angle is going to be the inverse sine of 1/2. But I know that the inverse sine of 1/2 is equal to pi on 6, according to my 1, 2, 3 trick above. So the inverse sine is equal to pi on 6. But here's the deal. We're talking about between 0 and 2 pi. So let's see if I've gotten all the answers. So I'm saying the sine of this theta value is equal to 1/2. I know the related acute angle is pi on 6. My ratio, if you notice, is positive. So I want to consider all the places where sine has a positive ratio. And that, of course, is going to be here where there's sine, and here where a means all of the values are positive there. I'm going to stick 2 terminal arms in those quadrants. There's one here, and there's one here. So this related acute angle is going to be pi on 6, and this related acute angle is going to be pi on 6. What I need to know is what are the actual angles that get me to there. So if I'm starting here, I have to go pi on 6 to get to the first angle. So I could say theta 1, the first angle, is equal to pi on 6. And then theta 2, let's do it in a different color. Theta 2 is when I start here and end up at the next terminal arm. Let's call that theta 2. And theta 2 is going to be 1 pi on 6 less than halfway around the circle. So it's going to be 6 pi on 6's minus 1 pi on 6, the related acute angle, which leaves me 5 pi on 6. So I have 2 different answers for theta that'll make that true. Okay, let's try that game again. Let's try B. If I asked you to find the cosine of theta, if theta is equal to negative root 2 on 2. So again, I can do my 1, 2, 3 trick, and you can just keep writing it over here if you want, just to help you remember. So we all divide them by 2, we divide them by 2, and then we take the square root of each one. So square root, square root, square root, square root. And then they go in order from smallest to largest. So pi on 6 is my smallest angle, then pi on 4, then pi on 3. Okay, so now we have that here. So what I would again write is, let's determine what the related acute angle. And the related acute angle is the inverse cos of the positive angle. We're looking at what is the smallest positive angle that we can be talking about. So whenever you find the related acute angle, you consider only the positive angle. And what that allows us to do then is, we know that the related acute angle is root 2 on 2. So cosine is my x, guys. So that's going to be, that's going to be pi on 4. And now I have to consider, okay, where, using my cast rule, is cosine negative, because the ratio is negative. And cosine's negative here, and cosine's negative here, because it's positive at the cosine and it's positive at the all. So I have 2 angles. I have theta 1, which takes me to there, and I have theta 2, which takes me all the way around to there. So I have 2 different values for theta within these restrictions. Okay, if the restrictions were different, then I might have more values or less values. So now I know that theta 1 is going to be, this is the related acute angle, which is pi on 4. So theta 1 is 4 pi on 4 minus 1 pi on 4, which is 3 pi on 4. And theta 2 is going to be 4 pi on 4 plus another pi on 4, because again, that's that related acute angle in there, plus another pi on 4, which is going to be 5 pi on 4.